Hi everyone, in this video we are going to practice going back and forth or converting essentially between different types of concentration units. So you should be very comfortable with going from ppm to ppb to molarity and back and forth into any kind of combination between the three of those. So let's start off very simply with just a very basic question. What is the molarity of a 45 ppm calcium that's aqueous solution? Go. Alright, did you get an answer? Hopefully you did, but if you didn't, please do not get frustrated. The first thing you have to do is get rid of this nasty ppm unit. So the way I do this is by writing 45 ppm, I cross it out, and then I rewrite it. So 45 milligrams per 1 liter of solution, which we said in this case was water. So now we're looking at 45 milligrams of calcium per every 1 liter of water. And now what we're trying to do is get rid of milligrams and convert it to moles because we're looking for molarity. So the first thing we have to do is get out of milligrams and into grams. So we know that there are 1,000 milligrams in every 1 gram. We're still talking about calcium, but now we need to get out of grams and into moles. So we're going to put grams of calcium at the bottom, moles of calcium on the top, and this is where we just use the molar mass or atomic mass off of the periodic table. And so calcium has an atomic weight of about 40 grams per 1 mole, and if you type this all into your calculator properly, you should end up with a molarity something like 0.001125 molar for our calcium solution, okay? So there's your molarity. Next question. How many grams of lead must be dissolved in 250 milliliters of water to create a 3 molar solution? Go. Alright, did you get an answer? This was definitely trickier. The first problem was a simple conversion. This one, there's a little bit more to it, so some students get tripped up here. If that was you, please do not get frustrated. And my biggest piece of advice is start with a single unit number from the problem. So what I mean there is that milliliters is a single unit, whereas molarity really is moles per liter. So kind of 2 different units in there, or a combination unit or a fraction. So I would definitely start with, if you choose to, the 250 milliliters. So let's start there, 250 milliliters. Now, we're trying to get to molar, which we said was moles per liter. So right away, you should be thinking, I have to get rid of milliliters. So let's just do that first. We know that there are 1,000 milliliters in every 1 liter. So now we're in the proper unit, but something still feels a little off, right? So what we need to do now is try to use that molar component. We have 3 moles per every 1 liter. So liters on the top here, so we need to get rid of liter, which is on the bottom. So 1 liter here, this is where you use your 3 molar solution. We know there's 3 moles of lead for every 1 liter of water, which is perfect because our 250 milliliters was of water, so it works out, yay. So now that doesn't solve the question. Now we're just in moles per nothing, right? Because our milliliters cancel out, our liters cancel out, we're left in moles. We just have to take it one step further to try to figure out how many grams of lead we actually have. Well, we know by using the periodic table that for every 1 mole of lead, we just use the mass off the periodic table, and if we remember properly, it's something like 207.2 grams. I had to look that up. I wouldn't expect you to know that. Now, if we multiply this all out and divide by 1,000, you should end up with the proper number, which is 155.4 grams of lead. Hopefully that makes sense. If not, stop, take a second, and actually calculate it out because we're about to ramp it up even further. Here we go. Number 3. 15 grams of magnesium have been dissolved in 15 milliliters of water. Is this concentration above or below normal tap water concentration? So for normal tap water, we have about 51 ppm of magnesium. Go. All right, so this problem is definitely a little bit complicated. There's a lot of different numbers here. We have a 15, a 15, a 51, so now we need to put it all together. So the first thing we want to do is identify that this is our reference point. So we're going to have to calculate a number and then compare it to 55 ppm, meaning we need to get our first answer, or our number, the thing that we calculate, into a unit of ppm. But like I said before, I don't really like that number. I don't like that unit. I don't like ppm. It's not an easy one to use. So personally, I would immediately convert this to 51 milligrams of magnesium per 1 liter of water. Now, milligrams of magnesium can get confusing. It's mg and then big M, little g, but just be careful and keep track of your units and you should be just fine. All right, so let's try to get our solution there, right? So we have 15 grams of magnesium in 15 milliliters of water. So let's just type that right in here. 15 grams of magnesium per 15 milliliters of water. All right, so we've started off with a very interesting ratio. We have our grams per liter. So we have our solute per solvent, which is perfect. Now, we know we need to get to milligrams, so I'm going to focus on that one first. because currently we're in grams. So we know for every 1 gram, there are 1,000 milligrams of magnesium. So now our grams are gone, we're left in milligrams, so that unit is done. Now what we need to do is fix our liter component, because right now we're in milliliters, so we need to get rid of milliliters and get to liters. Milliliters on the bottom here, so they need to be on the top. If we have milliliters of water and we're trying to get to liters of water, we know that in every 1 liter of water, we have 1,000 milliliters. So now let's check our unit. Our milliliters are gone, and we're left over in milligrams per liter, which is perfect. So now we just want to compare whatever number we get here to 51. So let's do that. If you typed it out in your calculator, hopefully you can see that this would be about 1 million. So a giant number, 1 million milligrams of magnesium per every 1 liter of water. So now, is 1 million bigger or smaller than 51? Hopefully that part you can do without even thinking, and it is definitely bigger, so we have above. All right, so the concentration that we've calculated for is definitely above the normal concentration of magnesium in normal tap water. Hopefully this makes sense. Again, if it doesn't, stop and ask questions. When we get to dimensional analysis, things get tricky really, really quickly, and the next problem, in my opinion, I think is the hardest of all 5 of these. So let's actually just try it. Let's just jump right into it. So this pulls in your stoichiometry, your dimensional analysis. We're talking about atoms and ppm. Whew, this is a hard one. Try it. You can do this. Go very, very slowly and methodically. How many sodium atoms are in 27 ppm solution? Go. All right, this was a tricky one. Like I said before, I think this is the hardest problem, so we're going to go through this slowly. The first thing we want to do is look at this part. That's the only number we have. It's the only one we can use. So we have to start with 27 ppm. We've said before we don't like ppm. It's not easy for us to do dimensional analysis. So what we do immediately is convert it to milligrams of whatever, so this is sodium in this case, per 1 liter of solution, which in this case is going to be water again. You just have to assume that if I don't tell you specifically. Now, we are in milligrams. We need to get to sodium atoms. So this is kind of a tricky one, all right, per every 1 liter. So we're in milligrams. We need to convert that one to atoms. First thing we do is go from milligrams to grams. So we know we have 1,000 milligrams of sodium in every 1 gram of sodium. That's pretty easy. Trying to get to atoms, if we recall, we have to go from grams to moles to molecules and atoms all at one point. So now we have 1 gram here, so we need grams of sodium on the bottom. We're trying to go to moles of sodium on the top. So this is where we use our periodic table. And we know for every 1 mole of sodium, we have about 23 grams. This is what we pull off the table. Usually they have it written at 22.99, something like that, but 23 is fine. All right, last step. We're almost there. Right now we're in moles, so if we cancel everything out, milligrams goes away, grams goes away, grams goes away. So we're left over in moles. We're so close. We just have to take it 1 step further and go to atoms. So we know for every 1 mole of sodium, you have Avogadro's number of stuff. So in this unit, or in this example, we're trying to use atoms. So for every 1 mole, we have 6.02 times 10 to the 23rd atoms of sodium. So if you type that all into your calculator and you do this properly, you end up with something like 7.06 times 10 to the 20 sodium atoms. Woo, that's huge. That's a big, 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 big number. And it's definitely correct, so hopefully you got that answer. All right, last one. We're going to end with something easy because I don't like ending with something that's that challenging. If you can do this problem right here, you should feel very, very confident that you will do well with this material on the exam. So what is the molarity of a 7 ppb copper solution? Go. All right, this one was definitely tricky, but not the trickiest, so I fully believe you can do it. Now, unlike the other problems, this one's actually ppb, not ppm. And so what we have to do is first get rid of that awful unit. So instead of saying 7 milligrams per 1 liter of water, so we're still going to do per 1 liter of water, now we're saying 7 micrograms of copper. All right, so now the big component here is we're just trying to get to moles per 1 liter. So our unit at the bottom is perfect. We just have to fix this microgram component. So we're going to go immediately from micrograms to grams because I think that's pretty much the easiest. So 1 gram of copper. So for micrograms, there's 1 times 10 to the 6 or 1,000,000 micrograms in every 1 gram of copper. We are so close to being done, but this is grams per liter. We need to be out of grams. We need to be in moles. So we know for grams of copper, we're just going to use the atomic mass off the periodic table. And we know that there's about 63.55 grams of copper for every 1 mole. So now we're left in moles per liter. We definitely have the right unit. If you do this properly, you should get something like 1.101 times 10 to the -7th molarity. Whew, this was a long video, but a lot of math. Hopefully you can do this. Please, 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 I cannot stress this enough. Please take a moment and actually calculate this out. This is one of the spots that students make mistakes, and it's just because it's so easy to just drop a decimal or think micro instead of milli. So you just have to take your time and be very, very careful. But aside from that, have a great week. Take care of yourself and drink water.